Okay, so in today's notes, we're going to take a look at Chapter 8, Section 3, Factoring Quadratics. This is straight out of your book, what I'm going to walk you through today. We've multiplied before using the FOIL method, and essentially what we're going to do now is move backwards. All right, so I'll walk you through this. If you don't get all the information you need or I go too fast this first time, feel free to go online to the class webpage, and on the right side under the column that says links, there will be a section called video links where you can go and watch the video again if you need to. Okay, so let's take a look. We can factor, um, if you look at it, we're going to factor the polynomials that look like this: x squared plus bx plus c. So we're going to start where the leading coefficient here is 1, and then there'll be a number here probably, and then a number here at the end. Um, the pattern for multiplying these can be used to factor certain types of trinomials also. So the FOIL method works where we multiply first outer and then inner last, and we get x squared plus 7x plus 12. And you notice that the middle term, and this is like a really important part of this middle term right here, 7x, is the sum of 3 and 4. So what we end up doing is we look for numbers when we factor that will multiply to give us this last number and add to give us this middle number. And again, this is specifically when we have a plus sign here and a plus sign here, and there's a 1 up front here that we don't see, but we know it's there. We're looking for two numbers that multiply to give us this last number and then add to give us this middle number. So a lot of times when you're given a problem, for example, x squared plus 9x plus 20, you can just start making a list. You list out the factors of 20, and then you add them together. So the factors here are 1 and 20, obviously, 2 and 10, and 4 and 5. So those are all numbers that multiply to 20. That's what's happening right here. What we also need to find, though, are two numbers that add up to 9x. So we need the same set of numbers, and really we quickly see that right here, 4 and 5, they multiply to 20 and add to 9. So what we're able to do is just rewrite this polynomial here as the quantity of x plus 4 times the quantity of x plus 5. The great thing about this unit is that you're able to check all your work. If you get this, just multiply the factors together and you should be able to get the original expression. Okay? So take a second and see, let's look at 1a first. So we need two numbers that multiply to 24 and add to 11. I'll give you a second to think about those, and then we'll go over how to do that one. All right, let's take a look at our list real quick. Factors of 24, that is too big. That's better. Factors of 24 are 1 and 24, obviously, 2 and 12, 3 and 8, and 4 and 6. So of those factors, we can just then add up their sums. So the sum here is 25, the sum here is 14, the sum here is 11, and the sum here is 10. Of all of these, which one of them add up to 11? All you have to do is figure out which of these terms add up to 11, and you really quickly see that it's 3 and 8 right here. So then what we're able to do is rewrite this in factored form. It's going to be one set of parentheses that has x plus 3, and then one set of parentheses that has x plus 8. Now, we could also write that in reverse order because we know that 2 times 3 is 6 and 3 times 2 is 6. So the order that we write those in doesn't matter. It just matters that we see that if we were to FOIL this back together, x times x is x squared, 3 times x is 3x, x times 8 is 8x, and 3 times 8 is 24. That 3x and 8x in the middle get added to be our 11x. And I know the whole time just now I worked with x, and that is very clearly a D. So I'll change that so that nobody has a hissy fit over what letter I chose. Take a look at B. B is the same kind of problem, it's just not in standard form. So the first thing I would suggest doing is rewrite the problem so that it looks like all the other problems. So t squared plus 10t and plus 9. I'm being very careful to make sure that I keep the signs with the correct terms so that I know what's positive and what's negative. Here they were all positive, so that was pretty easy. So then again, you're looking for two numbers that multiply to 9 and add to 10. Some of you are probably already yelling out what the answer is, so stop yelling. Especially if you're at home by yourself watching this on YouTube, it'd be weird to be yelling this at the computer. So t plus 9 times t plus 10, or excuse me, t plus 1. And that's it. That's all you have to do. That's factoring. That's dividing this up into two separate binomials. All right? Let's take a look at the next page. Factor x squared minus 8x plus 12. Here, the big difference that you can see is we have a negative right there and a positive right there. The concept is exactly the same, though. We're looking for factors of 12 that will add up to a negative number. Since we know their sum is a negative number and their product is positive, that means they both have to be negative. So when you make your list of factors, you want to include negative numbers this time. And what you see is that right here at negative 2 minus 6, those two numbers are going to multiply to positive 12 and add to negative 8. So then this time the answer right here is x minus 2 and x minus 6. Okay. The book also very neatly shows you a really nice way that you can check your answers using a graphing calculator. So I'll show you how to do that. If you go into your graphing calculator, I'll give you a second to get your calculators out. While you're doing that, I could talk about random things like flight patterns of birds. I don't know anything about that. I could describe to you how to make the perfect creme brulee, but I don't know how to do that either. I know you need a blowtorch, so it sounds fun. At this point, if you don't have your graphing calculator out, you don't have one or are probably in the bathroom because we've been in class for 10 minutes and you're already bored. So right here, it's y equals x squared minus 8x plus 12. That's the problem we started with. Right here, I have put in the answer that I got, and I want to use my graphing calculator to check if this is correct. So I'm going to click F6 to draw. And what I see is that I only get one parabola. I entered two equations, if you recall, 1 and then 2. If the counting there is difficult for you, just start at 1 and then go to 2. I only got one drawing, though. That means that they're over top of each other. They're overlapping each other. So because they equal each other, if two functions give us the same exact picture, then they must be the same function. So I can check my answers in my graphing calculator and see very easily that I got this one right. Let's take a look at the next page. So let's factor these. You'll notice the first thing we're going to do on these, just for neatness and understanding's sake, is we're going to change the order. We'll go just a little bit bigger. So we'll say that m squared, and then I got to make sure that this is a minus 22m. That really is important that that's not right. That we make sure that the sign goes with, I'm in a lot of trouble here, goes with the number that we're talking about. So I'm going to rewrite that as m squared minus 22m plus 21. So then I'm looking for two numbers that multiply to positive 21 and add to negative 22. So let's make a list. That would be negative 1 and negative 22. I could keep going, obviously negative 2, negative 11, but some of you probably were like, hey, that's it, and right on the first one, and you were right. So these two numbers right here add up to negative 22. They multiply to negative 21. So I'm ready to write my factored form now. M minus 1 times m minus 22. And it is just that easy, I promise. So take a second and get out your graphing calculator, which hopefully you don't have to get out, you still have it out, and we'll go in here and we'll enter each one of those in and see, just to make sure that we get the same thing twice. So the first one was, and I'll have to use x, x squared minus 22x plus 21. That's the first one. And then the second one was parentheses x minus 1. That's not what I wanted. That's what I wanted. X minus 1. And then parentheses x minus 22. So I have the problem, and then I have my answer, and I'll graph these. And sometimes this happens where we can't see what we graphed, but you can can do all sorts of things. View window, you could change that to standard, see if that fixes it. It's not going to, because standard is 10 by 10 and we're all the way out at 22 here. So I'm just going to go to view window and I'm going to make my X maximum way bigger. I'm going to make it 30 and then draw. You can also use the zoom button, you can do all sorts of things like that, but you'll see that we get the same thing twice. We don't. Hopefully somebody caught that before just now. That should be 21. Okie dokie. That is embarrassing. Let's go back up here and let's fix that. Don't tell anybody I did that. No one will know because this is on YouTube and not a lot of people know about YouTube yet. I can zoom in and out so I can see the whole parabola, but what I've done now is I've drawn the parabola twice and I get the same answer, so that one works also. Take a second, see if you can figure out this one. This one is in the order we like. It's in standard form. So we're looking for two numbers that multiply to 28 and add to negative 11.